right, we're back from our brief break, and I would like to introduce Andrew Carruthers. A native of Oxfordshire, England, Carruthers worked at the Lawrence Berkeley Research Labs in California before deciding to follow his passion for building stringed instruments. Returning to the UK, he studied at the Welsh School of Violin Making and Repair. After graduating, he joined the restoration workshops of Bein and Fucci in Chicago to apprentice under the guidance of master cello restorer Russell Wagner. In 1996, he opened his own workshop in Santa Rosa, California. He's been awarded 2 silver medals and a certificate for cello tone and a certificate for violin tone from the Violin Society of America. He uses the medium of violin making to explore both the natural world and questions about violin acoustics and aesthetics. So please welcome Andrew Carruthers. Please feel free to share your slides whenever you wish.
Hi, yeah, so thanks for that introduction. We're still good? Okay, so I'm actually in a hotel room at the moment, so I thought I'd just give you a quick picture of my workshop, which is in my garage in Santa Rosa. I work by myself there, and for the last 35 years I've been working on restoring valuable old instruments and making my own. Okay. So what I'm going to talk about today is a project that I started during COVID when work slowed down, and I had some time to explore some of the ideas and questions that I've been accumulating over all my years in the trade. And what I did was I started a series of instruments that I call offbeat violins, where I began to investigate particular aspects of violin making that interested me, but pretty soon that led on to considering other questions. And so in that way, the violin making became a sort of investigative lens on the world. And though these offbeat violins aren't traditional, I wasn't trying to change the direction of violin making. I was rather more interested in examining some of the peculiar things that we in the violin world take for granted. And I just want to note that a violin and a fiddle are the same thing, and I'm going to be using those two words interchangeably. So, in order to understand where I was going with these ideas and with this talk, I need to explain where violin's been. So, for the last 300 years, the sort of pinnacle of the craft has been to create exact replicas of a handful of violins that were made in the 1700s by 2 or 3 violin makers. And this rather odd situation of looking back has come about because the violin is rather a unique thing among man-made objects, in that it evolved over about 150 years. It sort of started in the 1500s, and that design evolved very slowly until about the early 1700s, when Stradivari came along. He kind of nailed the design, he sort of perfected it. And by that I mean that for a string tuned at a particular pitch and bowed and stimulated with a bow, and having that sound amplified by the you can't actually get more volume and a richer tone than you can with these instruments that were made, at that period. So what we've been doing ever since is copying those things as carefully as we can in hope of unlocking the secrets of the sound. And in many cases we've equaled that, but we've never actually surpassed it. The other thing that we do is, because those instruments are so valuable and sought after these days, and another peculiar thing about violins is that they're actually very durable. And these 300-year-olds plus up to 400-year-old violins are still in the world and still being played regularly. But the population's grown, and only a few, less of these instruments have survived, so they're very sought after and very valuable. So what we do these days in violin making is try to make exact replicas of them, and that means making our brand new instruments look antique. And in the last few years, 50 years or so, this has come to a real sort of peak where people are spending up to double the amount of time actually trying to make their instruments look old as the time that they put into making the new instrument itself. And there's nothing actually wrong with this, but this sort of looking back for me, after about 35 years of doing it, I began to feel rather like a musician who'd been told that, well, you know, all you can do is play Bach because he's the great master. So I started looking for ways to do something a little more interesting with my violin making time. So my first idea was to make a violin that showed how it was developed. And I wanted to do this because as we carve a violin, as we make it, or a cello or a viola, it goes through all of these stages that are very attractive looking, rather sculptural. And all of this carving, this lovely texture and line and rhythm that happens in there, it gets erased as we smooth the surfaces and finish them. And I'd always thought that it would be wonderful to create an instrument that sort of showed its work, rather like a math proof. So that's what I did. And when I started out on this viola, I thought, well, what I'm going to do is I'm just going to make the instrument, and whatever tool marks appear, I'm just going to leave those, and I'll finish the instrument and see how it looks. But as soon as I started carving, I started seeing all these patterns in the surface of the wood, and I started trying to make them more attractive. And here you can see on the back of this instrument, the left half has one sort of carving pattern on it, and the right half has...
Andy, I think we can't see your image.
Oh, really?
We're just seeing your workshop.
Oh. Well, that's a little difficult. I wonder what we can do about that.
There we go. That's it. Perfect.
You can see an image here. Okay, so it's not going to preview. So yeah. Okay. Okay. Let me go back a bit. Oops, not that. Sorry, I'm losing control of this. Okay. Well, it's kind of in edit mode, so they're not going to look as good as they could. So yeah, these are the offbeat instruments. This is a traditional violin, the sort of thing that we're trying to copy these days. This is a tonal spectrum of instruments to demonstrate how wonderful the classic period instruments are. And this is me experimenting with tool marks on the violin. So are these reading better now?
Yes, that looks great. Thank you.
Okay, good. Okay, so I realized what I was doing was making aesthetic decisions. And I had this personal revelation of something that I'm sure is sort of common knowledge to most artists, but there's certain tools that you can use, things like line and texture that are used by all artists. So, for instance, in poetry, you might talk about narrative line, or the pacing, or the rhythm of the narrative, rhyme, and so on. And those tools are exactly the same things that you can also use in painting, for instance, or in dance, to tell a story and convey emotions to the audience. So, keeping this in mind, I went on to try and finish the violin, and I started with just a uniform coat of varnish, and fairly attractive, but maybe a little boring. So I tried to break up the surface by adding some larger lines onto it. And in this case, it's certainly attractive looking, but perhaps a little chaotic. And it's nice to be somewhere in between. So I carried on, and using techniques that I'm quite familiar with from trying to make antique-looking new instruments. We call it antiquing. So using my antiquing techniques, I refined the surfaces by adding patina to the low areas and highlighting the high areas as if they'd been worn naturally. And I came up with something which I thought had a fair amount of texture and line and rhythm to it. Here's details of the scroll. I was always trying to make things look sort of organic, because that's something I think is quite attractive. And the sides of this instrument actually reminded me of the skin of a reptile of some sort. And so I thought, well, I could actually use a natural object as a source of inspiration for the aesthetic decisions that were being made. And so that's what I did with the next violin, and I decided to base it on a turtle. And the way I went about it was to use the same sort of color palette as a turtle shell. And I took those gouge marks that you saw in the viola, and I sort of formalized them. They were more random in the viola, and I'd sort of made them symmetrical. And these were supposed to sort of suggest the sclerets, or the plates that you see on a turtle shell. So one of the things I liked a lot about the way this came out is it has this sort of recursiveness. You can see in, I don't know if, yeah, where we're getting these sort of cell patterns, but then within the cells there's sort of repetitive, sort of recursive nature. And the overall effect, I think, is it has this rather interesting effect that it appears that you can sort of look inside the instrument. It's a sort of like an open sponge texture that maybe you could travel into if you were small enough. I also copied other features that I saw in reptiles and turtles. In particular, this F-hole was based on these extraordinary iris patterns that you'll see in some reptiles, these sort of slit irises with the notches, and so these notches became a feature. So, moving on, the next two instruments were a study in variability. And variety. So working on that turtle fiddle, it sort of reopened my eyes to the natural world. And I was actually, my undergraduate degree was in design and ecology, so I've always been interested in nature and the natural world. And thinking about the aesthetics and reflecting on what it was about these old, worn, handmade violins that make them so attractive to us, I realized that the violins themselves actually resemble natural organic forms in a number of ways. And one of the characteristics of natural objects that's particularly attractive and engaging to us is a quality of that I call limited variability, where at first look everything looks the same, but as you as you keep on looking and become familiar with these things, you'll see that everything is, as in natural objects, you get a variety, so you get variations on a theme, and as you become familiar with whatever the theme is, you become more sensitive to these variations, and that's what holds our attention to them. So I thought that perhaps if I could understand the causes and nature of variability a little better, perhaps I could make instruments that were just as attractive and engaging to us as the old violins are, but perhaps I'd be able to get there without resorting to making these extremely careful antique copies of them. So what are the sources of variety in objects? Well, I kind of got it down to four main sources: design, execution, materials, and age, where the design is the deliberate variation that was made. So what was the Violinmaker in this case doing to make this particular instrument different from the last one? What was the deliberate choice that was being made? And then with execution, well, how well was that design carried out? And that might well be limited by the skill of the violin maker, you know, how well he was in control of his tools, or what accidents happened along the way, and all of those things will add a little variety into the finished product. The materials used are very important, because different materials react differently to the making process. They react differently to the tools that are being used, and they also age differently. So in materials, if you think about wood, I mean that's something that has a lot of natural variety in it. Each piece of wood is slightly different as compared to something like steel or plastic, which the material is going to be very much the same from iteration to iteration. And then the final thing that happens, objects that we finish, they go out in the world and they get worn and used, and then over the years they accumulate the marks of age. And in violins that have survived a long time, I mean, that's particularly important. It's sort of a major factor. I mean, the violin on the left, the dominant thing that you see there is the effects of age. So, yeah, I set out to make a couple of instruments that sort of explored these various factors. And in thinking about it and researching it, I came across the work of Alan Turing, who is, of course, famous for his work against the Enigma machine, and also for inventing or laying the basis of modern computing. So later, after the war, he got very interested in morphogenesis and the question of how variety comes about in nature, and why is it, or how can it be that, say you've got 100,000 oak leaves from a tree, how can each of those oak leaves be recognizably an oak leaf, yet each one is individual? Or how does every leopard or every tiger have its own individual pattern? So I started looking at this, and I found somebody, Kiram Dundar, who's a design teacher in Istanbul, design professor, and he's been working with these patterns for years. And I asked him if he would be able to generate me touring patterns that were bounded within the shape of a violin. And we got together and he generated a number of patterns. So what happens here is you have a seed to the pattern, and then depending on the variables involved in the equations that are driving this program, it will form different patterns. But the pattern actually sort of reacts with itself. It actually comes and hits the boundary, and it sort of bounces back and reacts with itself. And under certain conditions, these patterns will just infinitely keep on varying. It's called an unstable reaction. So this was, I took as an example of design variety. So instead of actually designing each individual instrument with a different pattern to it, I was going to leave the computer to come up with a new pattern. So every time you would run this program, you would get a different pattern. So then I moved on to the next stage of the process, executing the violin, the pattern onto the violin. And I used hand techniques to transfer the design onto the violin, just carbon paper. And then I carved the pattern in by hand, and again, this was to introduce more variety into the finished instrument. And I think this amount of variety gives kind of a more organic look. Then I went on to finish the instrument using some of the antiquing techniques that we've developed in violin making, adding dirt, wearing highlights, polishing and stuff. So I was working on this, and I was posting pictures of these instruments on Instagram, and at this point I heard from Christy Reynolds, who is your symposium host, and she said she was very interested in these patterns because they resembled something that she'd been working on previously. And so Christy, would you like to say a few words about the patterns that you were working with, and why you had these patterns, and how they were derived?
Yeah, absolutely. So these patterns, so my background is fabricating telescope mirrors. So I work on ultra-precision optics for telescopes. And at the time, we were working on a telescope called the European Extremely Large Telescope, which is a 39-meter optical telescope. It has a primary mirror made up of 798 individual segments. And in order to make it possible to create these segments, we used CNC machines to polish out the curvature in the glass. The problem with that is typically with CNC machining, you'll raster back and forth. That was leaving behind a very regular pattern that was that would cause diffraction spikes in the optics. So the task that I was given was to figure out a pattern that we could use with the CNC machines that would visit the entire surface without ever crossing itself, but be randomized. So I wrote the MATLAB code. This is the algorithm right here that will produce these random walks. So first we create a grid. We set our boundary point. Usually this would be a telescope mirror, but in this case we made it for a violin. And next we fill this. This is called the Aldous-Broder algorithm. It creates what's called a spanning tree. So we add nodes to the tree that visit every one of those grid points. Got that. Then we add another grid, and then we find the points that neighbor that spanning tree. We drop out the spanning tree and then create a walk that walks along those remaining points that had neighbored the spanning tree from the Aldous-Broder algorithm. And that gives us a path that visits the entire surface in a random order without ever crossing itself. Every time you run the algorithm, you get a completely different pattern. So this was the unicursal violin pattern.
Yeah. So yeah, what's wonderful. This is a yeah. Yeah, so this is rather similar to the Turing thing in that every time you run it, you're going to get a different pattern. So variability is built into this. Every time you make a violin like this, it's going to be slightly different. And Christy ran patterns for all of the different panels. So we ran them for these are going to be the sides of the violin, and the back and the top. We also ran patterns for the scroll of the violin. And then so in this case, I've knocked some of the variability out. So instead of doing handwork on the instrument, I had these cut with a CNC machine, which not only carved the shape into the violin, the arch of the back and top, but then also superimposed these unicursal paths onto it. So going on to finish it, I used a mixture of inks and pigments that actually separated as they were drying. So it, again, produced a little more variability. I didn't know exactly how they were going to dry. It sort of created a pattern as the inks dried, the inks and pigment mixture. And then after that, this is the finished back of the instrument, and I've put it through my antiquing process again, where I've knocked off the highlights, the areas that would get worn, and I was really quite. At first, I didn't like this, but it grew on me a lot, and it has another characteristic of natural forms in that the more you look, the more you see, and you can go deeper and deeper into it and keep on seeing new stuff. And so, yeah, this is characteristic of natural objects, but with many of the man-made objects around us, I mean, if you look at a plastic cup, it's you know, it might be fairly interesting from a distance, but as you get closer, you're not particularly getting a lot more information at a certain point. Whereas with this, you know, each little region of the violin back had more and more texture and color to it. Here we're seeing little bubbles that are in the varnish. And it's also, the other thing is, back to this sort of theme and variation, there is a theme to it and a line to it. I mean, this color here is repeated over here with a slight, you know, more blue variation here and maybe a little more white over here. So this theme and variation thing that you see in nature that is naturally attractive to us. Here's the path that was carved into the scroll of the instrument, and on the top of the instrument variability coming from the materials used. So the top and the back of the instrument are made from different woods. The back of the instrument is maple, which is fairly homogeneous, but the top has hard and soft grain lines. And the interaction of that material with the machining process it gave a different result. So variability from the materials used. So nearing the end of my presentation here. So the four fiddles that I've shown you were based or investigating things to do with aesthetics within the violin world, and also the same sort of things in the natural world. But I made about 10 of these instruments in all, and other ones were more based or investigating tonal aspects of the instruments. So what I got from this was definitely a deeper understanding of the elements that we use in aesthetics. I also found out a lot about violin. Well, I got a much more intuitive sense about the way these violins function tonally. And one of the big questions I kept on getting was, how do these things sound? How does this carving and texturing on the outside of the instrument affect the tone? And it was actually a very good question because, as I say, in our trade, we copy these old instruments very, very precisely. You know, the graduations or the thicknesses of the backs and the fronts of the plates are copied to within tenths of a millimeter. Thinking that, you know, this is critical for the sound. What I found was that this actually didn't make a lot of difference, and the sound of most of these instruments was within the range of variability of tone that I get normally with my regular instruments. So I think one of the biggest lessons I've learned, and I think the final thought I leave you with, is that I did make a couple of these instruments using some of these features, but just simply in a decorative way, but without any sort of question behind them. And that left me with the idea that I think that the most interesting stuff, and maybe it's what you might call art, I think that happens when we're asking questions and about something and trying to find answers, exploring. Whereas the two decorated violins, I had pretty much the idea of how they were going to look at the end, and that to me is what craft does. We're setting out with a known end result in mind, and doing our best to get there. So I think that's an interesting distinction. Anyway, I'm going to leave it there, and I'll take any questions that you might have.
Thank you so much. I don't see any questions in our chat this afternoon.
Okay.
Do you have any projects underway for another offbeat violin?
I've actually, kind of relevant to what I was just saying, I've actually kind of come to the end of the questions that that have occurred to me. I would do it if I had interesting questions to answer, but it's gotten to the point where I'm just making them for decorative purposes, and it's not really that interesting to me. And so I've gone back to making the regular violins, but sort of armed with some of the insights that I've had and technical things that I've discovered along the way from doing these. I'm working on an experimental guitar at the moment, but as far as violins go, no.
All right. Well, thank you so much for joining us today. We really appreciate your time and expertise. Oh, wait, there's... Oh, I was curious if you've used lasers to carve patterns into violins.
I've thought about it, and I haven't. I think you could get some interest. I mean, yeah, you could get some very interesting effects. I mean, it would add some color as well, since I think the wood would burn. And that would be another way of adding, yeah, surface texture and surface pattern. I haven't done that, no.
Well, thank you for your time. We can let you go. Really appreciate you joining the symposium today.
Well, thank you very much. It was a pleasure to do this.
Thank you.